And out of this expression pop out two very important quantities that are the bread and butter of evaluation in medicine. That's sensitivity and specificity. These terms are also known by true positive rate and true negative rate, which refer to the same two quantities. Sensitivity is the probability that the model classifies a patient as having the disease given that they have the disease. Specificity is the probability that the model classifies a patient as being normal given that they are normal. Thus, we've broken our global measure of accuracy down into the useful quantities of sensitivity and specificity. The other piece of useful terminology is for the remaining terms over here. The probability of a patient having disease in a population is called the prevalence. The probability of being normal is simply 1 minus the probability of having disease, or 1 minus the prevalence. We can thus write accuracy in terms of sensitivity, specificity, and prevalence. Why is this useful? This equation allows us to see accuracy as a weighted average of sensitivity and specificity. The weight associated with the sensitivity is the prevalence, and the weight associated with the specificity is 1 minus the prevalence. This equation also allows us to find out any of these quantities given the other three quantities. Let's see this using an example. First, we compute sensitivity. Sensitivity can be computed as the fraction of disease examples that are also positive. So in the denominator, we have the number of disease examples, which is 1, 2, 3, and in the numerator, the number of positive and disease examples. So this is going to be 1, this is not going to be another 1, this is going to be 2. So we have 2 out of 3, or 0.67. Then we compute specificity. Specificity can be computed as the fraction of normal examples that are also negative. So in the denominator, we have the number of normal examples, which is going to be 7. And in the numerator, the number of negative and normal examples. This is going to be 1, 2, 3, 4, 5, not 6, 6. And this is 6 over 7 to get 0.86. So that's the computation of sensitivity and specificity. Now let's look at the prevalence of disease in this set. This is simply the fraction of disease examples computed as the number of disease examples over the total number of examples, which is 3 over 10, or 0.3. Now, using the relationship between sensitivity, specificity, and prevalence, we can also get to the accuracy. So this is going to be equal to 0.67 times the prevalence, 0.3, plus the specificity, 0.86, times 1 minus prevalence, so 1 minus 0.3 is 0.7, and this comes out to 0.8. And we can confirm with a simple calculation of the fraction that we get correct that the accuracy is indeed 0.8. Thus, we have covered two metrics we can use to evaluate diagnostic AI models, including sensitivity and specificity, and we've seen how they're related now to accuracy.